Hi aspirants, this is NLR Commerce Academy. So today we have started the theoretical distributions from business statistics. So theoretical distributions also known as probability distributions. So a random exponent is assumed as a model for the theoretical distributions, and the probabilities are given by a function of the random variable is called probability function. Once again repeat, a random exponent is assumed as a model for theoretical distribution, and the probabilities are given by a function of the random variable is called probability function. For example, if we toss a fair coin, that means 1, 2, 5 rupees coins also there, that we have taking 1 rupee coin, that is the called fair coin. 1 rupee or 2 rupee or 5 rupee or 10 rupees 20 rupees coins also there. The probability of getting a head is 1 by 2, not 1 to 1 by 2. Okay, that means the coin have two options are there. One is head, next one is tail, head or tail. Okay, if we toss it for 50 times, the probability of getting a head is 25 times. We call this as the theoretical or expected frequency of the heads. That means we have expected 25 heads from the 50 times of coin toss. Okay, but actually by tossing a coin in 50 times, we may get 25, 30 or 35 or 40 heads, which we will call as the observed frequency. Okay, once again repeat. For example, we are taking 1 rupee coin. We can toss one time toss. It is called head or tail. If for example we have success is there, head. Okay, in this situation we have tossed 50 times. Under the 50 times we have expected to the 25 heads, that is called expected frequency. So under 50 times coins are tossed, at that time 25 heads are there, 30 or 35 or 40 or total 50 also there heads, and this is the called observed frequency. This is the difference between the theoretical expected frequency or observed frequency. Thus the observed frequency and the expected frequency may equal or may differ from each other due to fluctuation in the experiment. Okay, so under that the types of theoretical distributions are three types. Number 1, binomial distribution. Number 2, Poisson distribution. Number 3, normal distribution or expected frequency distribution. So binomial distribution and Poisson distribution, these are related to the discrete series. Okay, normal distribution is related to the continuous series. You know that already. The data series are three is there. Number 1, individual series. Number 2, discrete series. Number 3, continuous series. What is individual series? It is identifying the individuality, single number 1, 2, 3, 4, 5. Okay, like that individual. It is the raw data. It is raw data, not grouping. It is called individual series. They are not grouping. It is the raw data only. So discrete series is particularly this type of variables are related to particular character, like that number 1, number 2, number 3, like that. How many classrooms in the school? How many classrooms in the school? Like that 10 rooms. Number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10. Okay, how many students in the classrooms? Number 1 classroom 50, number 2 classrooms 30, number 3 classroom 20 members, number 4 classrooms 30 members, number 6 classrooms 25 members. So this is the called discrete series. Okay, that means the data is particularly related to the character of the such type. It is compulsory divided. Okay, but in the continuous series, it is a grouping data. It is means integral, interval are interconnected. We have not separated. Okay, like that heights, weights. So this type of data is not particularly divided. For example, how much of height persons, like that 0 to 10 age persons height, it is the different. Like that number 12 months age boy height, it is the different heights is there. Like that one boy is 20 centimeter 40 centimeters, one boy is 45 centimeters, one boy is 50 centimeters. Like that, that means 12 months by height, it is between the 40 to 50 centimeters. It is not particularly classified. So it is intervals also there, that is the 0 to 10, 10 to 20, 20 to 30, or 0 to 100, 100 to 200. So it is classified, it is there. So these type of classes also there. It is called the continuous series. So binomial distribution and Poisson distributions are related to the discrete series. Normal distribution is related to the continuous series. So now we have discussed to the binomial distribution. So the prefix bi means two or twice. Okay. So binomial distribution is related to the two or twice. Okay. A binomial distribution can be understood as the probability of a trial with two and only two outcomes. It is a type of distribution that has two different outcomes, namely success and failure. Also it is applicable to discrete random variables only. That means we have taken any distribution or any data that have take only two, that is the success and failure. We have expected success if failure is chance is there. We have expected failure, the success is also there. Okay, that means we have taking one, that one have success or failure, any one outcome is there. Okay, we have taking one, that one have two outcomes. So that's why bi. Okay, bi. So under the two outcomes only one is there, only one is there. So that is the process binomial distribution. Okay, in the under the binomial distribution we have taking example kind. Okay, the kind is trial is there. Once trial, the kind we have expected to the head. If head is there, that is the success. If tail is there, that is the failure. We have expected head, but is tail, it is failure. Okay, so it is also known as Bernoulli distribution. It is associated with the name of a Swiss mathematician James Bernoulli, also known as Jacques or Jacob, 1654 to 1705. That means the birth is 1654, death is 1705. Thus the binomial distribution summarized the number of trials, survey, experimented conducted. That means trials, kind trial, survey, we have expected to the survey for success or failure. Like that we have taking the toothpaste brand. For example, we have taking Colgate toothpaste brand, we have taking in particular area. How many persons are used Colgate toothpaste brand? For example, we have taking 100 members. Under the 100 members, we have expected to the more than 80 members. 80 members are using Colgate toothpaste brand. we have survey. That survey how 80 members are used, it is related to the success. If less than 80, it is failure. Okay. Or experiment, we have experiment to the any other trials, physics, like that, sciences. Next, it is a very useful when each outcome has an equal chance of attaining a particular value. The binomial distribution has some assumptions which show that there is only one outcome and this outcome has an equal chance of occurrence. The number of trial or the experiment must be fixed. Every trial is independent. None of your trials should affect the possibility of the next trial. The probability always says the same and equal. The probability of success may be equal or more than one trial. Okay. Once again we have discussed. For example, we have one coin we have taken. That coin is tossed. We have expected head. If head is there, that is the success. Tail is there, that is the failure. If we can coin tossed, head is there, we have success. Then next second one, the coin is tossed, the coin is tail. Okay, it is failure. That means first outcome is not affected to the second outcome. There is no change the kind. No change the kind. Like that, we have taken at a time 10 coins are tossed. 10 coins. That means 1 rupee coins we have taken 10 numbers. Okay, 10 coins are tossed. Under the 10 coins, 5 heads, 5 tails also there. Nothing but we have expected to the 50% chance is there. 5 coins are heads. Okay. Then next to same 10 coins are tossed. Okay, same 10 coins are tossed. If you have tossed only 9 coins, that time the binomial distribution is not applicable. That time the binomial distribution is not applicable. That is one is there. And under that we have taken coin or survey, any experiment that have only one outcome. We have expected two, that is a success or failure, but only one outcome is there, not two outcomes, only one outcome. So this is the assumptions. Negative binomial distribution. Negative binomial distribution for selected values of the parameters r and p. Nothing but we have expected to the negative. That means our result also negative side. That is the called negative binomial distribution. So binomial distribution model characteristics. That means dichotomous outcomes. That means two possible outcomes. That is how one outcome can occur. Okay, two possible outcomes. That means we have taken coin, head and tail. Two possible outcomes are there, but we have tossed only one outcome is there. That is the can occur. Constant probability of success. The success is independence. That means any task or any event is expected or any event is dominated to the another event, not dominated. Okay. So binomial distribution mathematical model. That means the formula is there. P of r is equal n, capital N into NCR. That means combinations p to the power of r into q to the power of n minus r. Once again, P of r is equal capital N into NCR into p to the power of r into q to the power of n minus r. R is equal number of successful outcomes. Okay. For example, we have tossed the 50 coins first time, the 0 heads also there. If second time 50 coins are tossed, 20 heads also there. This is the called 0, 20 or 1, 2, 3, 4, 5. This is the called R. Successful outcomes. N number of events or trials. We have trial 50 or trial first time, second time, third time. Okay. P is equal probability of successful outcome. For example, P is the probability of successful outcome means we have taken one kind, that is head or tail. Okay, the kind having two outcomes, but success is 1. At that time P is equal 1 by 2. So Q is equal 1 minus p. 1 minus p means, for example, you are taking p is equal to 1 by 2. 1 minus 1 by 2 is equal to 1 by 2. Q also. P and Q, these two values are always less than 1. These P and Q values are compulsory less than 1. If more than 1, the fitting of distribution is not implicated or not possible. So, NCR combination formula is equal NPR by R factorial, or is equal n factorial by R factorial into n minus R factorial. Okay, that is. Next, under the binomial distribution we have calculated mean. So, n into p. Okay, n is equal number of outcomes, p is equal success. Standard deviation under root of n into p into q, variance is equal n into p into q. We have calculated mean. So, next we have discussed to the Poisson distribution. Okay, it is the second one. It is also related to the discrete series. The Poisson distribution, that is a very useful in situations where the events occur in a continuous manner. Poisson distribution is utilized to determine the probability of exactly x is equal to 0, 1, 2, 3 number of successes taking place in unit time. It was developed by a French mathematician Simon Denis Poisson 1781 to 1840, but this Poisson distribution developed in 1837. 1781 is the birth of the Poisson, 1840 is the death of the Poisson. Let us now discuss the Poisson model. At first, we divide the time into n number of small intervals such that n to infinity. We have taking n to infinity, 0 to infinity, and p denote the probability of success. We have taking the two outcomes is there, that is the success. So, as we have already divided the time into infinity small intervals, so p to 0, so the result must be that condition is n into p is equal lambda, or a finite constant. It is also called the n into p is equal mean under Poisson distribution. So, modal characteristics, that means characteristics of Poisson distribution. Time interval or spatial region. We have taking spatial region under the control of scope. We have taking the data, that data is scope. For example, area of the distribution. Probability of an event is small. Events are independent. That means one event is not affected to the another event. Events take place at a constant rate. Events take place at a constant rate. So, these are the characteristics of Poisson distribution. So, under the mathematical model, P of x is equal to r. I have taking r is equal to 0, 1, 2, 3. That is the called is equal e to the power of minus m. So, I have taking calculation, m means mean. So, mean value we have taking the Poisson distribution table is there. Under the table we have taking the log basis. The table mean value is containing to the table value. We are taking table value. P subscript is the Poisson distribution. X is equal to Poisson random variable. R is equal to number of events that occur. E is equal to natural logs base 2.713. That means maximum mean is equal to 2.713 we have taken, but the mean is variance, different numbers also there. At that time we have taking the table. The table have numbers is there, that is taking. M is equal to mean number of event occurrences. So, mean or arithmetic mean is equal to n into p, same formula under the binomial distribution. Variance is equal to is different, sigma square is equal to m into 3. So, under Poisson distribution we have discussed some matter is there, that is the Poisson distribution is useful. What is the difference between the binomial and Poisson distribution? Because these two are related to the discrete series, but what was the different? Okay, what was the different? So the Poisson distribution is used to describe the behavior of rare events. Okay, so that's why it is called the law of improbable events. Like that, printing mistakes in a book. How many printing mistakes per page in book? This type of, and it is mostly useful in the rare events such as serious floods, accidental release of radiation from nuclear reactor, okay, and earthquakes. So these type of situations occur. At that time we have using the Poisson distribution. Okay, so this is the difference between the binomial and Poisson distribution. Next we have taking the normal distribution. The Poisson and binomial distribution is related to the discrete series, but normal distribution is related to the continuous series. The normal distribution defines a probability density function f of x, frequency of x, for the continuous random variable x considered in the system. The random variables which follow the normal distribution are ones whose values can assume any known value in a given range, like that height range 10 centimeters to 20 centimeters or 100 centimeters to 150 centimeters. How much of candidates also there, that is the range. Okay, it was first described by the Abraham de Moivre 1667 to 1754 as the limiting form of the binomial model in 1733. That means it is the described in the year 1733. The limitation of binomial model overcoming the normal distribution. So normal distribution was rediscovered by the Gauss, Karl Gauss in 1809 and by Laplace in 1812. That means first person is Abraham de Moivre. The next is elaborated by the Gauss and Laplace. Both Gauss and Laplace were led to the distribution by their work on the theory of errors of observations arising in physical measuring process, particularly in astronomy subject. Okay, so we hence extended the range to minus infinity to plus infinity, and total negative values as well as total positive values. Continuous variables are such random variables, and thus normal distribution gives you the probability of your value being in a particular range for a given trial. The normal distribution is very important in the statistical analysis due to the central limit theorem. The theorem states that any distribution becomes normally distributed when the number of variables is sufficiently large. For instance, the binomial distribution tends to change into the normal distribution with mean and variance. Like that, the binomial distribution is and Poisson distributions are related to the discrete series, but we are taking huge data. At that time it is continuously there, that means interlinked data is there. So at that time the continuous series is applicable to the binomial, and Poisson distribution also is there. The normal probability density function is f of x is equal to 1 by sigma on the root of 2 pi to the power of e to the power of minus x minus mu whole square by 2 sigma square. That is, x is equal to value of the continuous random variable mu is equal to mean of the continuous random variable, sigma is equal to standard deviation, pi is equal to mathematical constant approximately 3.14159. Like that we have taking that the normal distribution table is there, we have taken table, that is the called E is equal to mathematical constant approximated 2.71828, sigma 2 pi is equal to 2.5066 values. It is the different from the percentage values. That is the taking normal distribution characteristics. The distribution is symmetric, its skewness measure is 0. Like that we have taking y x axis is there, y axis is there, the bell shape is there, equally divided. It is the middle is equally divided, left tail and right tail. It is skewness measure is 0. The highest point on the normal curve is the at the mean. The mid value line is white color line is dot line is there, that is the called mean, divided into the both side, which is also the median and mode. That point also. The mean can be any numerical value, negative, 0 or positive, but the normal distribution curve is always bell shaped. You can see that 0 to minus 10, it is also bell shaped, minus 10 to plus 10, minus 10 to plus 10, it is also bell shaped, 0 to 20, between the 20 value, you can see that minus 10 value middle is there, bell shaped, 0 value mean is there, bell shaped, 20 number is there, that is the bell shaped. It is negative, 0 or positive, it is the skewed. Normal distribution curve is skewed. The standard deviation determines the width of the curve. Larger values result in wider or flatter curves. That means the value is larger, that curve is flatter. Okay, that is the wide range is there. For example, sigma is equal to 25. The tails are width is elaborated, but in the sigma is equal to 15, the width is narrow. Okay, the curve width is middle is the blue color line is the sky blue color line is sigma is equal to 15, the width is smaller, which is compared to the sigma is equal to 25, the width is wider. So that is the width of the curve, larger values result in wider range. So wider range values are larger, flatter curves, that means sky blue line, the wide flatter curves values are smaller. Okay, now probabilities for the normal random variable are given by areas under the curve. We have understanding the total area under the curve is 1, the curve is 1, at that time 0.5 to the left of the mean and 0.5 to the right of. That means the white color dot line is called the mean point, average or arithmetic mean point. It is divided to the 50% in the left side and in the right side, that is the normal random variable area. So we have taking normal distribution characteristics also we have discussed. 68.26% of values of normal random variable. We are taking the normal random variable 68.26%. These values are within the plus or minus 1 standard deviation of its mean. 95.44% of values of normal variable are within the plus or minus 2 standard deviation of its mean. 99.72% of values of normal random variable are within plus or minus standard deviation of its mean. We are taking the graph also there. Next, this one we are taking first line, you can choose plus or mean minus 3 into sigma, that means mean answer and minus the 3 into sigma answer, that value, and in the y-axis right side mean plus 3 into sigma, mean answer plus 3 into sigma answer. This coverage area is the normal random variables total covered under the 99.72 percentage. The next, mean minus 2 into sigma, it is the negative, mean plus 2 into sigma positive under the between 95.44 percentage. Okay, and mean minus 1 sigma and mean plus 1 into sigma under between the 68.26 percentage variables are non-random variables. Under these limits also we have taking. Okay. A random variable having a normal distribution with a mean of 0 and a standard deviation of 1 is said to be have a standard normal distribution. The letter Z is used to designate the standard normal random variable. So the formula is there, Z is equal x minus mean by sigma. We can think of Z as a measure of the number of standard deviations x is from mean. That is. Thank you.